Hey, what's up everyone? In this video, we'll be learning about sets. So, let's dive in. Sets are built-in data types in Python that are used to store and ordered collections of unique items. So in short, sets are just lists that don't allow duplicates and does not maintain the order. So maybe you can just revisit lists. So when learning about lists, we had something like this, where we had a list of ages that had 12, 34, and that's so. And maybe if you can see this, there is 34 here and 34 here. Sorry, they're duplicates. And if you need to get the number of 34s that are there, you always use the count. So you can just say something like count, then I put the value that I want to get the number. So if I say count 34, count is a method, so I have to put ages.count, not just count, because this is a method and you say that lists are just objects. So you say ages.count, and if I save this code and run it, you see it will give me the value 2, because there are 2 instances of 34. But with lists, you don't allow repetition. This is not allowed in lists. So to create a list, let me just convert this into a list. I'll just remove this square bracket and put curly brackets like that, and that will become a list, and that will become a set. And with sets, there's no duplicate. So if I print this, if I try to print these edges, you see it will print all of them, but 34 will just be 1. The extra 34 will be removed. So you can see that 34 will only be 1. And you'll also notice that this order is not the same order that we wrote. So sets is just a list that has no duplicates and there is no specified order. So the order in which you write them is not the order in which they'll appear. And that is what we call a set. And in sets you can do something like ages.count, because I've already said that a number cannot have duplicates. So if you say ages.count, it will be an error, because now sets, there is no duplicate, so you cannot come up with the count of it because there is no duplicates. Instead, if you want to check if an item is in a set, you can use the in keyword. So I'll just say, maybe I can just say 12 in ages, like that. And if 12 is in ages, it will tell me true. It will just tell me true, to mean that 12 is in ages. And that is how we use sets. So let us learn more about, that was just an introduction, so let us learn on how you can create sets. I believe I've already seen that, and we can learn more about set as we progress. Also, a set can contain any data types. It's not a must that you put the same data type. For example, I can just add, let's say add here something like a string. Let me say 12. You can see that is a let me just say 2. You can see that one is a string, and if I just print ages there I did before, you can see it will just work fine. So a set can contain any data type, just like what we did in lists. But the thing with sets is that you cannot have duplicates, and also the order is not preserved. So the order which you write here is not the order that will appear there when you print. So the other of creating sets is using the set constructor. So to use the set constructor, you just put your variable. Let me just say I put my variable here, like let's say names, and I say is equals to set, like that. This way you'll have created an empty set. Then once you have the empty set, you can just add items to that set, and you'll see how to add items in a set in just some minutes to come. Then this set function can take an argument, and that argument is just any collection. For example, let's say this ages, it was a list. Let's say you had this ages is a list. Now you can pass, let me just call this variable unique, or just say u ages to mean unique ages, like that. So you can pass this, you can pass an argument to this sets function. Like if I pass this ages here, and this list will be converted to a set. And you can pass any collection here, not a must a list, but any collection, and it will be converted into a set. Now if I run this code, you can see now the ages will be converted into a set. Now I printed the wrong ages. Suppose I print the u ages, u underscore ages, like that. And if I run this code, you'll see now the list is now a set, and these duplicates have been removed. So this set constructor is mostly used to remove duplicates, and that is the whole idea of sets. There are no duplicates. Also, if you want to access items in a set, so let me just go back to what we had before. We had a set of ages, so let me just go back to this. We'll come back to this later, so I'll just remove that. So if I have this set and I wanted to access each item of that set, Set does not have that indexing that we had in list. So to access an item and each item of a set, you can do that using the loop. And in this case, the for loop is one is advisable. So if I wanted to access each item of the set, I'll just say for edge in edges. And we learned about this syntax in the for loop. So if you don't know about the for loop, you can just visit that video and see how you use the for loop. Then if I print each edge, if I print each individual edge, you'll see now if I run this code, I'll have access to each individual item of that set. You can see all the items are there in that set. So allow me to remove this 34 because it will not be added. So if you put a duplicate in sets, it's not an error, but set will just ignore that duplicate values. That's why I removed that 34 because it's not useful. It should just be ignored, like it's not there. That's why I removed it. Okay, the other thing with sets is that sets are mutable. So sets are just mutable, unlike tuples, which we said that they're not mutable. So sets are mutable. That means that you can add items to a set and also you can update items of a set. So to add items to a set, you can use this add method. I can just say edges.add, or let me just go back to the one that we add. We have the names. You see here we created a new set using this set constructor, and if I wanted to add some things in this set, I can just say names.add. Let me add, let's say done. And now if I print names, you can see names will be a set that contains the string done. You can see edge now names contain done. And that is how you add items to a set using the add function. Add method, not function. The add method works fine, but you can only add one item at a time using the add method. But if you wanted to add multiple items, you should use this one called the update. So with the update, you can add more than one item in a set. So if I wanted to add more names in the name set, I'll just say something like names.update. Then inside here, I can just pass more than one. So let me just pass a list. I'll just say maybe Mary and Phil. Now if I print names, you'll see now my names set will contain Dan, Mare and Phil. And you can see now those are 3 names. And I added more than one item to the set using the update method. To remove items from a set, you can use the remove method. So for example, if I wanted to remove Mary from this name set, I'll just say names.remove. And I'll pass the item that I want to remove. In this case, I want to remove Mary, so I'll just pass there Mary. And if I run this, if I print names will just contain Dan and Phil. Mary will have been removed. You can see that it contains Dan and Phil. You can see it says don't just they put in any order. The order does not take into account the order. That's discussed at the beginning. So I'll not explain that again. And this remove method raises an error if you try to remove an item that is not there. For example, if I try to remove John and John is not present in the names set, it will raise a key error. And if I run this code, you can see that there's a key error because they're trying to remove John and John is not there in the set. So if you don't want to come up with this error, there's this discard that ignores if an item is not there, it just ignores. So the discard is also used to remove a specified item from the set, but the gadget discard is that it does not raise an error if the item is not found. So if I just replace the remove with discard, let me just show you. If I just use discard, then I discard Mary will be removed from the set, and the set will just contain Phil and Dan, as we saw before. And if I try to remove John and John is not there in the set, nothing will happen. There'll not be an error will not occur, unlike the way you saw with. You can see the code just ran fine. No error is prompted there, and that is the advantage of using discard over remove. So if you want an error to pop, if an item does not exist, you should use remove. If you want it to not pop an error if the item is not there, you can use discard. The other method that you can use to remove items from a set is this one called the pop method. And how this pop works, let me just show you. So if I wanted to remove, I'll just call names.pop. Then this pop does not take any argument, so just say names.pop. And if I run this code, you can see it removed done. You can see done is not there. It removed done. So how this pop works is that it removes, I think it just removes any item randomly, and it returns that item that it removed. So if you are to store this in a variable, let's say removed, like that, then we try to print that removed. Let me just print here removed and run this code. You'll see it will remove an item, then it will give us that item that it returned. You can see now it removed Mary, and the value of removed will now be Mary. And since you saw that sets don't have a specific order, it just and this pop just removes, I think pop removes the first item, so it just removes any random. And since the order of sets is not strict, it just pop just removes a random value. So I'm not sure how we'll use this pop, but maybe you can just find a use case where you can use the pop. And just to mention, if the set is empty, for example, if I remove these lines of code here, let me remove this removed and also remove these lines of code so that our set can be empty. If the set is empty and you try to pop it, that will prompt an error. It will be a key error. So if I run this code, since the set is empty, so that this one is an empty set, so that will be a key error because you cannot pop from an empty set. So that is the thing maybe I can just mention. And the other method to remove items, this one called the clear. So clear removes all items from the set. I think you have learned about clear from the past videos. So if you just say clear, it will remove all items from the set. Maybe I can just print the set before and after. Let me just print these names before the clear and after the clear. So before I clear, I'll print the names, then I'll print the names after. Or maybe I can just print them after, because to avoid confusion. So if I just clear and remove and print names, you can see names will be an empty set. This is how an empty set looks like. Just set and like that. So yeah, that is it with the changing items from the set. The next thing is this one called the set operations. So set supports several mathematical operations such as union, intersection, difference, and symmetric difference. And allow me to use this example here because this is just simple. I'll replace all that with those two codes. So here I have two sets, A and B. A contains 1, 2, and 3, and B contains 3, 4, and 5. So the first operation is the union. So with union, you combine items from both sets, but you remove the duplicates, just like how we saw. So if a union is this, you just put this pipe symbol. So maybe I can just say, I can call that variable union like that. Then I get the union of A and B. So I'll just write A, then I put this pipe symbol, then I write B. So this union will be a set that combine items from both A and B, but it will remove duplicates, just like how we saw that sets cannot contain duplicates. So in case I had here I have 3 and here I have 3, this union will just contain 1, 2, 3, 4, and 5. This 3 will not be duplicated because I've seen initially that sets cannot contain duplicates. So if I just print this union, we'll see it will just contain 1, 2, and 3. 1, 2, 3, 4, and 5, not 1, 2, and 3. 1, 2, 3, 4, and 5. The other 3 will be removed. And that is how the union work. The other thing is one called the intersection. So intersection is this and sign. This and. It includes items that exist in both sets. So if there's an item in set A and set B, that is what will be printed. So if I just change this one to and like that, maybe I can just change the variable also. I can just call it intersection because we said that variables have to make sense. Let me just call it intersect. And if I run this code, you'll see now the value of that will be 3 because 3 is contained in both A and B. And that is how the intersection works. The other thing is the difference. So for difference, it includes items that are in the first set but are not in the second set. So this first set contains 1, 2, and 3. The second set contains 3, 4, and 5. So items that are in the first set, not in the second set, is just 1 and 2. So I'll use this difference. I just put that dash like that. Maybe I can also change the variable to difference or just diff like that. And if I run this code, you'll see that the difference between those two sets will be the items that are in set A and not in set B. So just like in math, A minus B is not same as B minus A. Because if you write B minus A is like the items that are contained in set B and not in set A. So if I just swap this to B minus A, I'll just get different results. Because now I'll get the results that are, the items that are in set B and not in set A. If I run this code, I'll get 4 and 5. And that is how the difference works. The other thing is this one called the symmetric difference. So the symmetric difference, it includes items that are in either set but not in both. So if I just say A, then I put the symmetric difference, it's a caret, this sign, and if I run, I'll get 1, 2, 4, and 5. Because if item is in both sets, it will not be included. So I'll get 1, 2, 3, 1, 2, 4, and 5. 3 will not be included because 3 is present both in A and B. And those are the 4 common sets operations. So the next thing that we learn is this one called the set methods. And you've already learned about the add, you have learned about the update, you have learned about remove, discard, pop, clear. I think we've already learned about this set method. So the next thing that we learn is this one called the frozen sets. So we have said that sets are mutable, but there are some special types of sets that are immutable, and they are called the frozen sets. So frozen sets are just sets that are immutable. So it's just like a tuple that does not have duplicates. We said that sets is just a list that has no duplicates, and now frozen sets are just a tuple that does not have any duplicates. Let me just show you how to create the frozen sets. So if you want to create the frozen set, use this frozen set function. So I can just say, maybe I want to create something that I don't want to change. Maybe I can say, maybe I don't want to change student marks. Once they're recorded, they'll not be changed. You can just say marks. Then I'll call that frozen set function here. Just say frozen set. Frozen set. It's a function. Then I can pass a list there. So I'll just pass marks of students, like let's say the first student got 84, then the other one 34, 86. So those are just random marks that students scored. So this is a frozen set, and if I just print it, it will just work fine. It will just work like the normal sets, how they work. Marks. You can see it'll just be just a set. It'll just sit there in the terminal. You can see it's just a set, and the order is not preserved, but it has this frozen set up here so that you can know it's a frozen set. So once, maybe if I try to add something to this set, if I just say something like marks dot add, then I try to add, let's say 59, then I run this code, it will prompt an error. Let us wait for it. You can see it will prompt an error, and it will tell you that the frozen set has no attribute called add, because you have said that the frozen sets are immutable. So since the frozen sets are immutable, you cannot add to it. You said that immutable means not changed. Once you have created it, you cannot add or remove items from it, and that is what immutable means. So that is it. That is what you had for sets. See you in the next video where we'll learn about dictionaries in Python. Peace out.